but we have to refresh our memory. When I square, what is this? A plus B. It has a name. Excellent. When I square a binomial, what do I get? Thank you very much. Do you need me to show this? It's okay if you say show. Please don't be shy, because I don't want to go back to this. Do I need to show?
Show.
Okay, so once we deal with this, now it's done, and for the rest of the semester, we don't have to mention it again. So today is still the 3rd. Okay, so when we square a binomial, that's the general form. I hope you agree that we really have this. Acceptable? We're going to FOIL it for the last time, I hope. So this is a times a, which is a squared, a times b, which is positive ab, b times a, which is still positive ab, and b times b, which is b squared. Since these two terms are like terms, we will always remember that a binomial squared is first term plus second term squared equals first term squared plus 2 times the first term times the second term plus the second term squared. Because you may not be given a and b, and you will not be given a and b. I guarantee that. So therefore, this is a squared plus 2ab plus b squared. And when we have, instead of a sum, a binomial sum of terms, we have a binomial difference of terms, what do you think will change?
No.
This is still the same. I'm ready.
The sign of the 2ab.
Exactly. It's a squared minus 2ab and plus b squared. Finally, for the last one, this is called the difference of squares. And let's FOIL it for the last time. So it's a plus b, a minus b. A times a is a squared, ab plus ab, but minus b squared. Well, it happens that this time there is no 2, because these 2 cancel out each other out. So I have a squared minus b squared. So that's our a squared minus b squared. So I'm hoping that moving forward, we don't have to mention this. But of course, if you have questions, I will not say, oh, I'm not answering. Of course, I'll answer. But I'm hoping that moving forward, because I always get that question at some point in time, where is this 2 coming from? Well, this 2 is coming from the fact that there are 2 terms that are like terms, and that's why we add them, and we get a 2. So as an example, can anyone square this for us? And no, we don't want to FOIL. Everyone can FOIL. My algebra students can FOIL. The first term squared minus 2 times 3 times 4 x squared y cubed plus
16y. Or this 6.
perfect. No problem. So that's what I expect you to come up with. The first term squared minus 2 times the first times the second plus the second term squared. That's exactly what this means. So if this is just a refresher, I will immediately put it in here and say when I square binomial, this is what I get, blah, blah, blah. Okay. Any questions on this? So we do have this agreement with these 3 special products moving forward. Agreed? Okay, perfect. Okay, so now let's continue with this. So let's look at each problem and decide whether we want to see this right now or we know it. So I made myself a note I need to bring you a copy of the recommended homework problems, a copy of the limits, and a copy of the assessment, the skills assessment for next time. Good. So I'm ready. Let's read the first problem. Find an equation for the line that passes through the given point and is parallel or perpendicular, I mean both, we have to do both, to the given line. Is it a yes or is it a no?
Yeah, let's go through it.
Okay, perfect. So we start with 2x minus 3y equals 4 and the point negative 2 comma 3. So let's read it again. Find an equation for the line that passes through the given point. Okay, so I'm not graphing anything. I'm just giving you the idea. So there is a line whose equation I don't have that passes through the point negative 2 comma 3. And this is unknown. And it says is first parallel, okay, parallel to the line whose equation is given. The line has 2x minus 3y equals 4. It is your obligation to stop me if you have any questions, please. Anytime. Okay, so yes, what do we do? Yes, why will I solve this equation for y as negative 3y equals negative 2x plus 4? When I move a term from one side to the other, you can still write minus minus if you'd like. Do not change something that works. I will show you a method. If you find that my method is easier, adopt it. If you don't find that my method is easier, then don't. I'm fine. You will not hurt my feelings if you prefer a different method. That's fine. Okay? So I move 2x to the other side, so it becomes negative. And now I will divide both sides by negative 3. Let me see what's in here. What is this? Okay. So then y equals 2/3 x and minus 4/3. Okay, so we solve for y. Then, first of all, why did we do that?
One parallel is going to have the same slope.
Yes, see, we were only now we are able to compare these two equations. This is the slope Y-intercept form or slope-intercept form of the equation of a line. So now, only now I can read or identify the slope. Once I have the slope, I'm going to call this M2. M sub 2 equals 2/3. Then I will say that M sub 1 must be, of course, because lines are parallel. And then I have a point and the slope. So now y minus y1 equals the slope times x minus x1. This equation is point slope form, in which I have the point which is negative 2 comma 3, and I have the slope which is 2/3. It's not done, but I just got it prepped. Any questions so far? So then y minus 3 equals 2/3 x plus 2. So minus negative 2 and minus 3. I distribute to get 2/3 x plus 4/3. 2/3 times 2/1. 4/3, and then I bring 3 to the other side. So then finally y equals 2/3 x plus,
13/3.
yes, 3 times 3 is 9 plus 4 is 13/3. So in case you forgot how to add fractions, I hope not, but the least common denominator is 3. 3, 3. You don't have to multiply by anything. You don't have to write 1. I'm just making a point. 1 was multiplied by 3. The numerator has to take the same thing. That's how we get the 4 plus 9. which is 13. So this is the equation of the line that passes through the given point, and is parallel to the given line. Now the scenario is different. We want this. It passes through negative 2, 3, but this time is perpendicular to the line whose equation is y equals, because we solved it, 2/3 x minus 4/3. This time the line is perpendicular. The unknown line, whose equation we don't have yet, is perpendicular to the given line. So nothing changes when it comes to the given line. The slope m2 is still 2/3, but now slope m1 is a different story. So when two lines are parallel, slopes have to be the same. But when two lines are perpendicular, they form 4 90-degree angles. It's a different story. What is the relationship between the two slopes when they are perpendicular?
Negative intercept.
Right. So that's perfect. However, I recommend, again, I'm not trying to change anything. Do not change. If it works, keep it. So you said this. I say this, which is identical. I just cross multiply. Only because it's shorter to say. Product is -1. Instead of telling you the slope of the perpendicular line is the negative multiplicative inverse of the slope of the first line. Perpendicular, product -1. Yes.
Not used to your handwriting yet. What is
M1,
the second line?
M1, M2.
Okay.
M1, M2, sorry. I stand and sometimes my handwriting is not. Sorry, my apologies. So they're all M's. Slope M1, slope M2. Slope M1, slope M2. So it's your preference. They are the same. Either this or this. You don't need both. So choose the one you like and stick with it. Okay, so in that case, can anyone give us the slope of M1? The slope of the first line, which is M1. Very good. Do you agree with -3/2? Yes, because if one number is 2/3, what do I multiply it to get -1? Of course, it has to be -3/2. There is no other way. Now, in order to determine the equation of this line, I have the same thing, y minus y1 equals the slope times x minus x1. Then the ordered pair is the same, and this time the slope is -3/2. That's the difference. Any questions? We're going to finish it up. Any questions? So y minus 3 equals -3/2 x plus 2. Now when I distribute, I get -3/2 x. This time I only have -3, and luckily I bring over a +3, so this is -3/2 x. Any questions? Yes. Anything? You hear something? It's probably the overhead. Does it bother you?
Okay.
Do you want to come closer? You come closer.
Okay.
I have to tell you that as a single child, I grew up without other children around me. And everybody was tiptoeing when I was reading something. And I lose concentration very easily. So I understand if that's the case with you. I fully understand it. Sometimes I do put earplugs in to stay focused on what I'm trying to do. I do very little work at work in my office because it's, so I can't. So I fully understand if you want to change seats, go ahead anytime. Okay, so let's take a look at this because this is a very important type of problem. Okay, so the first question I have for you here is I see a graph, correct? Is this a function?
Yes.
By the vertical line test, this is a function. For each x, there is only one y value. Okay, can anyone give us the domain of this function? So this is x, so this is 0, this is 1, this is -1, this is -2. Maybe I should put them in. So this is 0, this is -1, -2, 1, 2, 3, 1, 2, 3, -1, -2, -3. Yes, so the domain is between -3 and 3 on the x-axis. So I'm going to write the domain, -3, 3, domain. What about range? So that's the domain. So what about range? Yes, so from the smallest y value till the largest y value, -2 to 3. So the range, -2 to 3. Remember, we use brackets when the point exists. We use parentheses if the point does not exist. But both points exist, this one, the endpoints, and this one exists, so it has to be -2 to 3 with brackets. Okay, so I'm going to ask here, find f of 1. Yes, please. Because otherwise it would have been like this.
Oh, okay.
That would have not been part of the graph. So then I would have had, in that case,
right.
-2, 3 like this. Sure. Okay, so f of 1. Very good. F of 1 is 2. So we draw, or we imagine that we draw a vertical line through x equals 1. It crosses the graph at this point, and we read the y value. Do you all agree with f of 1 being 2? Okay. Let's say what happens when estimate the value of we can choose any other if you want, but I'm more interested here. For what values of x is f of x 1? So now I'm looking at f of x being 1. What do I do at this point? I draw a horizontal line, y equals 1. And I see that it crosses the graph in 2 different points. And I will read those x values for those points. Of course, I have to estimate. So it's somewhere between 0 and 1, but it's somewhat closer to 1. So whatever you say, I'll accept it. What will you say? X equals point what? 0.6. I accept that. What about here? It's closer to -3. What would you say? X equals? -2.8. I accept. Perfect. Okay. We say the domain and range. Now, what does this mean? In other words, right. So, yes, thank you very much. So, f of x equals 0 means find X-Intercepts. Also, the same thing is find the zeros of f of x. Or just simply the solutions of f of x equals 0, right? Okay, so we see that the function crosses the x-axis here and crosses here. So you will say maybe roughly 0.4, yes, and maybe roughly negative 2.5. So the x-intercepts, I will say x equals 0.5 and negative 2.5, or 0.4 and negative 2.5. Any questions on this? What about the y-intercept? Yes, I would say the y-intercept as an ordered pair is 0, negative 1. Any questions on reading from the graph? One of the things I would like you to tell me from this graph is, which is not here, what does the function do between negative 3 and negative 1? Yes, excellent. It's decreasing. What does the function do between negative 1 and positive 3? Increasing. So we write f decreasing. I'll post this, of course, and you'll have a copy next time. So it's decreasing on the interval negative 3 comma negative 1 and is increasing on the interval negative 1 comma 3. Is the function ever constant? No. Very good. Okay, moving on. Here's the next question. Find the domain of this function. I want to copy it here. F of x equals the square root of x squared minus 4 over x plus 5. Okay. So this is a combination type of function. It's not a pure anything. It has a ratio. It has a radical. We're asked to find the domain of this function. How do I do that? Awesome. So what is the first condition then that I have to state? Yeah, but let's write it from raw before we move on. Exactly. That's all I needed, and then we'll solve it in a minute. So whatever you want to see. Excellent. Okay, now what? Is there anything else?
Like x squared minus 4 because it's in a square root has to be like greater than or equal to 0.
You are the first student who likes square root. I have yet to get in 24 years that answer from the first time I put a radical function on the board.
Just had to freak out.
Who was your professor? Tim
Yes.
is my buddy. Excellent. So I have to call him and thank him for that. Okay, I will do it. Excellent. So, question. Do we understand the second condition?
No.
Okay. When we look at the function, and we're going to have to review a lot of functions in their graphs. When we look at this function, the square root of x, can anyone say what to write about this?
The shape of the graph.
No, first of all, the domain. Every time we are talking about any function, we refer to the domain first. So I'm sorry?
It can't be negative?
Correct, but we have to write this.
Okay.
Correct. So then when we graph it, you can use a table and so on and so forth. Here's the graph of the square root of x. The square root of x basically has two conditions. Under the square root, I can have only positive, sometimes 0. But if it's in a denominator, I cannot have 0, right? But greater than or equal to 0. But also the final answer is always greater than or equal to 0. Not just that under the square root, I have positive or 0. But also the final answer is y value is always positive. Look at the range. So therefore, when we look at the square root of x squared minus 4, we have to stay the same restriction. No matter what I have here, I have to stay the same restriction, that this has to be greater than or equal to 0. So otherwise, I can take the square root from a negative number. I can take the square root from 0 or positive, but not from a negative number, and get a real number. Right? We're talking about real functions here. So that's why x squared minus 4, for the same reason why x is here greater than or equal to 0, for the same reason x squared minus 4 has to be greater than or equal to 0. Otherwise, the radical doesn't exist as a real number. Is that okay? Moving forward, you have to remember that, okay? Perfect. So now I have two conditions. I'm going to write them again. I have that x plus 5 cannot be 0, and I have that x squared minus 4 has to be greater than or equal to 0. Perfect. Okay. So then from here, I know that x cannot be. We already said that, but now I can solve the condition. X cannot be negative 5. But now I have to talk about this. What type of inequality is it? Because if I identify it correctly, I have great chances, high chances that I will solve it correctly. So what type of inequality is it? Oh, okay, let me list a few and you'll tell me what type of inequality it is. Rational, linear, polynomial, quadratic, absolute value, exponential. Thank you very much. I was going to continue. I had at least 5 more to list. Okay, it is quadratic. How do I solve a quadratic inequality? I have to see what you consider as the next step before I say yay or nay. So if we set it equal to 0, what do we find? So we find the solution. No. I'm not saying it's wrong. I just want to hear all the steps. So okay, that's one option. We will set it equal to 0, then find the solutions, and then that's okay. Perfect. I accept that method. I just want to show you a different one. I accept it. Do not change anything. That works. Okay. So this will be a terrible mistake. Please. You cannot take square roots from both sides of an inequality. You can from both sides of an equation, but you cannot do this with an inequality. So please do not do that. Okay, so here's what my recommendation is. Factor, because you can. We just reviewed that 20 minutes ago, right? So it's a difference of squares, and I factored it. In the next step, I will use a little table. I will not get credit or take credit for something I did not invent. So all these little tables that I'm going to show you, I was taught that way. I find them easy to explain, but I will not ask you to use them if you have a different method or you don't like my little tables, which I will not take credit for, as I said. X is the variable in this problem. It can be anything between negative infinity and infinity. Then I will list the first factor. I will list the second factor, and I will list what I'm interested in, which is the entire thing. I don't care for x minus 2, I don't care for x plus 2, but I care about the product of the two factors. Now, can you please tell me when is x minus 2 0? What is the 0 of x minus 2? What is the 0 of x plus 2? So now tell me in the ascending order, from left to right, which number goes in first? And then 2. So there is a 0 under one of these two numbers for x minus 2. Under which one? Good. There is a 0 for x plus 2. I know it's silly because there is only one factor. Good. Now please tell me what happens with the product when one of those two factors is 0. Of course. Of course. Good. Now, what type of functions we see here? X minus 2, x plus 2. What type of function is it? Good. Does it have a positive slope or a negative slope? Does it look like this? Or it looks like this? Number 1 or number 2? Good. Which means it comes from which values? And it goes to which values? Three subintervals. On the first subinterval, I multiply two negatives. What is the sign of the outcome? In the middle, I multiply a negative by a positive. And last? Good. Now I'm looking here, and I will determine what I need. Which sign is greater than or equal to 0? We only have two. Which sign will be greater than or equal to 0? Good. Is the product for this ever positive? For which x values? Yes, that's it. So negative infinity to negative 2, union 2 to infinity. Because that's where the product is positive. If you pick between negative 2 and 2, this product will be less than 0. Okay, we're back now to what we had. We had two conditions. One condition was this, and the other condition is this. Now we have to intersect the conditions, right? So when I graph this, which I really don't need to, but let's graph it for now. I don't care for units. This is this, right here. But I have to remove negative 5. That's not a problem. I'm removing negative 5. And finally, I can identify the domain of the entire function. What is the domain of the entire function? Thank you, Tim. Any questions?
Your videos still have audio as well?
Yes. Yes. I turn it off because I don't really like hearing myself. But yes. Yes, of course. I know what you're going to do. You're going to send this to Tim. You can, please. That's fine. Questions? Moving on. Yes? Okay. So let's look at finding the domain of log. So this is g of x, log base 3 of x plus 4. I would like us to review log before we do anything else, and before we come back to this function. So log in any base is the inverse function of exponential. So here's the exponential function with a base greater than 1. which is increasing on all its domain. And sometimes I have students in the middle of the semester and they say, can I still get something in the class? Can I pass this class or whatever? And I say, of course. As long as from now on your grade follows an exponential function with a base greater than 1, yes. It's the fastest growth. Good. The other one is this. So this is a to the x, but a is between 0 and 1. As you see, when the base is greater than 1, the function is increasing. When the base is less than 1, the function is decreasing. Both functions, both shapes, the exponential function is 1 to 1 by the horizontal line test. For every y value, there is only one x. For every y value, there is only one x. So therefore, they have inverse functions. Whenever I graph the function and the inverse on the same coordinate system, I have to graph the line y equals x, which bisects the first and the third quadrants. So all I have to do is just symmetrically reflect over y equals x to get the log function, the graph of the log. So this is log base a of x with base greater than 1. So if you try to fold these two functions, they will overlap. I missed it a little bit, sorry. So what am I trying to prove here is that the exponential function is defined everywhere, but has range what? 0 to infinity, but that's reversed for the log. Domain 0 to infinity, range everything for the log. For the domain for the exponential function is infinity, negative infinity to infinity, and the range is 0 to infinity. When we reverse those, we create a domain and range for the inverse function. So I call log a non-friendly function. I call exponential friendly because I don't have to worry about it. But here I have to worry about it. As you see, this is a vertical asymptote. So this function has domain 0 to infinity and not 0. So x must be greater than 0 for the domain of this. But now log base 3 is not applied to x, is applied to this. Therefore, what do I have to write?
X plus 4 greater than 0.
That's it. So the domain of this function will be negative 4 to infinity of this function. I didn't finish the graphs here. So the second shape is when the function has, the exponential function has a base less than 1. And notice something very important. The increasing function did not cross y equals x, but the decreasing function crosses y equals x. This must be a point of the inverse as well. How come? Okay, it's not 1, 1, but let's say if this point is 1, 1, please reverse it to give me a point for the inverse. 1, 1. So if the function crosses y equals x at a point, the inverse must cross at the same point. So this is log base a of x with, of course, a between 0 and 1. Both increasing, both decreasing. Still domain 0 to infinity. Range 0 to infinity. Domain all real numbers for the exponential. Range all real numbers for the log. Good. Any questions so far? So we understand why this is like similar, not the same at all. But keep those in mind together. Log is applied to something greater than 0. Square root is applied to something greater than or equal to 0. Any questions? Okay, moving on. Find the domain of the following function. Yes or no? Yes?
Yeah.
Okay. So we have h of x equals tangent x plus pi over 6. I'm looking sometimes to see, sometimes it happened a couple of times in the last 10 years that my video was not recording or something. There was a glitch in the system. And so every now and then I look and check and see. Okay, so we know that tangent is sine x plus pi over 6 over cosine x plus pi over 6. We know that, right? Tangent is sine over cosine. So what could be the problem with this function? What potential situation I may encounter is exactly. So I have to solve this equation. Remove those x values that create the denominator 0, and therefore find the domain of this function. Okay, so let's analyze a little bit cosine. Let's look at the unit circle. Here's the unit circle. Where is cosine 0? First of all, where do we measure cosine? We have two options. A function, sine or cosine, is measured on the x-axis, and the other one on the y-axis. The one that is the opposite of a central angle, the opposite, will be measured on the y-axis. The one that is the adjacent will be measured on the x-axis. So where is cosine measured? It's not the opposite. The opposite leg is sine. So it cannot be measured on the y-axis. So let me picture that for you because you may have forgotten. So a central angle is this. This is the opposite, and the unit circle has 1 as the radius. This is the opposite. This is the adjacent. And this is 1, and this is angle alpha right here. Central angle alpha. So what is the opposite then? Thank you. And what is the adjacent? Yes. So we measure cosine on the x-axis, and we measure sine on the y-axis. Excellent. So now let's find where on the unit circle I see 0. Where is cosine 0? So here is positive 1 because it's measured on the x-axis. Here is negative 1. Exactly. Here is 0. I shouldn't put it that. I should put it pi over 2 and 3 pi over 2. But this point is pi over 2 comma 0. And this point, I'm sorry. I meant 0 pi over 2. Okay? So this is 0 comma 3 pi over 2. I'm going to change that, of course. I meant 0 for x, y is pi over 2. But this is not what I'm interested in, actually. So this point is 0 comma pi over 2. But what we're interested in is basically to say that cosine x plus pi over 6 is 0 when x plus pi over 6 is, and x plus pi over 6 is. And you will say either pi over 2 or 3 pi over 2, but that's not sufficient for all possible solutions, plus 2 pi k plus 2 pi k. K is 0, plus or minus 1, plus or minus 2, and so on and so forth. Also, this point is basically on the unit circle is 0, 1, and this is 0, -1. Okay, so let's go back to these two equations because they're not done. Do we understand what we wrote for x plus pi over 6? So for cosine to be 0, this angle has to be either pi over 2, which is this angle, pi over 2, and or the other option is when the angle is 3 pi over 2. The reason why we wrote plus 2 pi k, how come that I don't write pi k? Well, because cosine has period 2 pi. That's why I write 2 pi k, 2 pi k. What does this k mean? When k is 0, I get pi over 2. When k is 1, I get pi over 2 plus a complete rotation. When k is 2, I get pi over 2 plus 2 complete rotations. And I can go on forever in other direction with k positive or negative. Because we want to find the domain. We just don't want to just determine where cosine is 0 within one complete rotation, but forever. Okay, so the only thing I need to do is subtract from pi over 2, pi over 6, move it to the other side, and move this to the other side. So then I get pi over 2 minus pi over 6 is 90 minus 30, so this is pi over 3, and plus 2 pi k. And the other one is 3 pi over 2 minus pi over 6. We find the least common denominator. We multiply this by 3, and we get 9 minus 1, right? So I got 8 pi over 6. Or I simplify and I get 4/3. So this is 4 pi over 3 plus 2 pi k. So this is one, and this is the other. And you can say that's wonderful, but what is the domain? You solve the trig equation. I should have asked what equation we're solving. So we're solving a trig equation. Fine. You solve the trig equation. Now what? Give me the domain. And I will say all real numbers except pi over 3 plus 2 pi k and 4 pi over 3 plus 2 pi k, where k is 0, plus or minus 1, plus or minus 2, and so on and so forth. This is the domain. All your numbers except those angles. And there are infinitely many because of k. Any questions on this? Okay. So here's our best friend now, the exponential. So we talked about that already. Any questions, please? Don't be shy, please. Anything. Okay, so y equals e to x plus 2 minus 3. Okay, what do? It says present a domain and range and graph it. Well, first let's talk about e to the x. Well, e to the x, we just looked at exponential functions. Is it increasing or decreasing on real numbers? Right, because the base is greater than 1. So here's how it looks like, e to the x, exactly like the other ones. The pure exponential function will always cross when x is 0. Which means 0, 1. Good. So the first transformation on e to the x will do what, if you remember? Shift left. Very good. 2 units. So this point moves here. Which point? -2, comma, comma, -2, 1. So here it is. So this is e to x plus 2. Remember, what is this? Yes, y equals 0, horizontal asymptote. When we shift a graph with a horizontal asymptote, either up or down, what happens first? The asymptote has to be moved. So the asymptote was at 0. If I move the graph down 3 units, where does the asymptote go? Asymptotes are not part of the graph. It happened that that was the the x-axis. I didn't have to do anything about it. So I shifted 3 down 3. But now please tell me, where does this point move? This is my reference point. Where does it move? So it would be at -2, comma, -2, comma, -2. Awesome. 1, 2, 3. Now I don't know where to graph it. I don't know if we to graph it like this. I don't know if we graph it like this. I don't know if it crosses the x-axis on the negative side, on the positive side, the y-axis below the x-axis or above the x-axis. I don't know. Very easy to find out before I finish my graph. And can you give me the range? We haven't even finished graphing it, but we know the range. Yes, -3 to infinity. Perfect. Okay, so I would like us to determine the x-intercept and the y-intercept before I graph it, so I don't have to go back and adjust the graph later. So the x-intercept, how do I find it for any function? Of course. Thank you. I said y equal to 0, which means e to x plus 2 minus 3 equals 0. Perfect. What do I do? What type of equation is it? Exponential. Very good. Thank you. Exponential equation, because the exponent is the variable. Good. What would be our first step towards finding this?
Okay, isolating e by itself.
Perfect. E to x plus 2 equals 3. Excellent. What now? I have to apply natural log to both sides. Excellent. The power becomes a factor in front. Do we remember the properties of log? Yes. Natural log e is 1. Excellent. Thank you, Tim. So x plus 2 equals natural log 3. So then x equals -2 plus natural log 3. I grab my calculator, or I'll show you here. So -2 plus natural log 3. And I got -0.9. Perfect. So -0.9 comma 0. Fine. So if it's -0.9 comma 0, then I know, and we'll find the other one in a minute, I know where the graph is going. Now what about the y-intercept? Excellent. So I have to find f of 0. So how much is 0 plus 2? 2. E to the second power minus 3. Perfect. Here's e. E to the second power minus 3. 4.4. So this is 1, 2, 3, 4. Up here. It has to be smooth, continuous function. If it hurts my wrist, I know something is wrong. So this is the final function, e to x plus 2 minus 3. Any questions? So this is, yes, please.
At the very beginning, when you shift from the e to the x and e to the x plus 2,
Correct.
you shift over -1. How did you get to that? Like shifting over just 1?
No, I did 2. So this is -1, this is -2. That's why I wrote the point is -2, +1.
Oh, it's starting at 0.
Yes, this point moved here.
Okay, it was starting at 0.
Yes, yes, no problem. Any questions? No, I think we talked about these, but if you would like to just look and see if you still would like us to work on 8 or 9. If you say no, then we'll move on.